Hi there, and welcome to part one in a multiple part technical series on laser plastic welding. So the goal of this part of the technical seminar is basically to give a general overview of laser plastic welding in an unbiased approach, not tied to one specific system supplier, and so on. I also want to cover the main benefits and guidelines, teach you how to implement laser plastic welding, as well as learn to spread the word to others, whether they be colleagues or people in your network. First of all, I'd like to cover some of the traditional plastics joining technologies. Most of you are familiar with plastic components and maybe in some cases how they're joined together. I want to cover four specifically just to give some context for this discussion. The first I have up here is snap features, and basically drawbacks to snap features are they require complex injection mold tooling, some different slides and different things that are more costly to implement, as well as they take up space in the part, bottom line. Fasteners are the next one. They're an added cost and they create extra features in the part as well. So as a consumable, it's an extra cost. It may not be much, but still 2 cents for a tiny screw. Maybe you have 10 of them in your assembly. Well, you can do the math if you're in the millions of components per year. Another technology, of course, is glue. It's probably one of the most simplistic methods of bonding plastics, whether it's a UV curable glue or so on and so forth. The bottom line is that it's messy and it lacks precision. End of story. Ultrasonic welding is one of the newer plastics joining technologies, all things considered. And there are some certain benefits to it. You don't need consumables, you can save some space and different things, but there are a couple drawbacks to it. One is it can damage sensitive electronics inside the part because of the vibration, the frequencies that the tools are vibrating at, and as well as it can damage Class A or outer consumer visible surfaces. Okay. Next, I'd like to give a little bit of an introduction on laser plastic welding, and usually what I like to do is I like to kind of bring about a point to those interested in the technology, and that is if your current joining technology is working for you, whether it be ultrasonic welding, gluing, screw fits, so on and so forth, and there's really no quality fallout or any big pressing issue why you'd want to look to a different technology, then I'd say it could be that you need to stay with your current joining technology, as laser plastic welding can tend to be a little bit costly to implement at first. But if you can learn to think holistically throughout the whole product life cycle, then I think it definitely can make sense in a lot of cases. Bottom line is I just like to counsel people to think about it, weigh it, compare apples to apples, and identify if it is something indeed that is worth it for your application. So where does laser plastic welding fit into joining technology? What I like to say is that laser plastic welding picks up where other joining technologies leave off. If there's a need to eliminate quality problems and miniaturize designs, all while avoiding damage to sensitive electronics, then laser plastic welding is the right choice. And I would counsel you to think holistically at this point. So I want to cover some of the features and benefits to laser plastic welding. There are quite a few of them. I'm going to cover about 12 of them here with you. First one is precise control of the welding area. So again, the laser beam is steered around the profile of the part in a very, very precise manner, whether it be a galvanometer scanner or even CNC servo controlled. So you can get that beam exactly where you want it to go within a very tight tolerance. The welds look good, aesthetically pleasing, especially if you have a translucent or transparent upper component. Looking through that, you can actually see the weld seam, and it's exactly where you want it. There's no melt ooze or any sort of other issues that happen as a result of the welding process. You can hold much tighter tolerances with laser plastic welding. You don't have any damage to the surrounding areas, materials, or sensitive electronics. So we call the heat affected zone is very, very small and stays just barely outside the weld rib, within a 1/4 millimeter or 1/2 millimeter, depending upon the beam thickness and so on and so forth. It's what I call a perfectly hygienic method of bonding. It means there's no other mediums that get introduced during the welding process. No particulates are generated from the welding process. A big one is you can miniaturize your designs. A lot of my Customers that were looking into this technology in the past were looking to shrink down their designs or make the inside electronics bigger and want a smaller wall of plastic around it, making the part more aesthetic or just smaller in general. Very, very important point. You can do 3D and complex shapes within reason, depending upon beam refraction and some of the other issues that come up with when you shine a laser through a piece of plastic. And we'll cover those again later in one of the later parts of the seminar. You can remove cumbersome part features like we talked about in the traditional plastics joining technologies, whether it be snap features or screw bosses. Those can be eliminated. Another big one is you can eliminate consumables, fasteners, glue, so on. Big one is you can drastically improve the quality because of several process monitoring steps that you can do while laser plastic welding. You can actually drive your quality up considerably and monitor closely parts that are welded good or not okay. A big one is that the bonding strength is virtually as strong as the base material. So very, very strong. And doing testing in the applications lab, when you're trying to break apart parts that are optimally welded, they usually end up damaging the surrounding area. It's kind of like when you're putting glue into two pieces of wood, usually that joint, that glue joint is almost as strong, if not stronger in some cases, than the wood itself. So if you can ever break that apart, then you're going to see material on both sides, both halves, basically. In the end, lower total cost of ownership. This is a big one. And again, thinking long-term or holistically, taking all things into account. Quality and miniaturization and space saving and consumables. Think about all those things all together, and that gives you a good picture on if laser plastic welding is good for you. Definitely a good benefit. All right, so the definition of laser plastic welding. It's a method of joining two polymers by subsequent transmission and absorption of laser energy. Okay. Further defining, when two plastics are clamped tightly together, a laser beam in the 1000 nanometer range, or 1 micron, penetrates the upper layer and is absorbed by the lower layer, which in turn is heated by the laser energy and transfers this heat to the upper layer, resulting in both of the plastics melting and mixing to form a bond that is virtually as strong as the base material. This is the core to laser plastic welding right here. If you understand this phrase, you will understand the keys to it. So, with that being said, I hope this has been helpful. Again, this is just a small, quick introduction to laser plastic welding, a little bit about what it is, some benefits about it. So I hope that you will follow along in the next seminars. I hope to be releasing these soon. There will be quite a few of them. This is a very in-depth technology, and I would like to share this with you and hope that it can find a place in your application. Again, thanks for listening or watching.